Okay, so today in section 2.7, we're going to be looking at analyzing graphs of functions as well as piecewise defined functions, and then we also have the greatest integer function. Now, when we're looking at analyzing graphs of functions, what we're going to really be looking for is what type of symmetry does this graph display? And that is closely tied to whether the function is an even or odd function. Also, we want to look at what are some relative maxima and minima values for a function. What's the end behavior of a function, as well as what are the intervals where the function is increasing? What are the x values where the function is decreasing? So intervals of increase, decrease, and also constant behavior. The first thing we're going to look at are our tests for symmetry. All right? So down below, you will see that we have a few pictures where we have symmetry properties being displayed. We'll come back up to the purple box here in just a minute. But the lady here with the glasses, you notice that there is a symmetry about this vertical line right here. So usually people's faces are symmetric about a vertical line. This would display symmetry about the y-axis. Okay, and that is going to occur if you have some xy ordered pair and you have a negative x with the same y ordered pair that goes with that. That would be symmetry about the y-axis. So we'll see on the first bullet point up here, to test to see if a graph is symmetric with respect to the y-axis, we're going to substitute a negative x in for x in the equation, and then do some simplifying and see if that is the same thing as what we started with. The bird down below, okay, this thing is a reflection on the water down below. So we would say that this is symmetric about, okay, the x-axis. It has a horizontal line that it is symmetric to, and we know that's going to occur if we have an xy ordered pair here, and we would have also a x negative y ordered pair down here. So right up here on the second bullet point, it says the graph of the equation is symmetric with respect to the x-axis if we substitute a negative y in for y in our equation, and we get an equivalent equation. Now, this flower represents actually both symmetry about the y-axis and symmetry about the x-axis, okay? But it also demonstrates symmetry about the origin, okay? Think about where the origin is. It's right there in the middle. And so we're going to see symmetry about the origin when we have these points that are satisfied. If you've got an xy ordered pair, and then also the graph would contain a negative x and a negative y, then we're going to say that we have that symmetry displayed about the origin. Okay? So up here, we're going to test to see if some kind of equation is symmetric with respect about the origin. We're going to substitute both a negative x in for x and a negative y in for y. Okay? So just summing up what we did here, if you want to see if a graph is symmetric about the y-axis, you replace x with a negative x. Simplify. If you want to see if a graph is symmetric about the x-axis, you replace y with a negative y and simplify. If you want to see if a graph is symmetric about the origin, you're going to replace both x with a negative x and y with a negative y. Let's look at an example. Here we are given some equations, and we're going to do the three different tests to see if the graph is symmetric with respect to the y-axis, the x-axis, or the origin. Okay? So keep in mind, and I kind of like to put this in a box up here, so I'll know what to reference. First of all, to see if our test is symmetric about the y-axis. Recall from the purple box above, that means we're going to be replacing x with a negative x. So we're going to see if y is equal to the opposite of the absolute value of, here comes the negative x, minus 4. If that, when we simplify it, will be the same thing as what we have in the box, our original equation. Okay? Well, the y doesn't change. Okay? Bring down the negative sign, and then let's think about what do these absolute value bars do. Well, you know, the absolute value of a negative x is going to be the same thing as just absolute value of x. For example, absolute value of negative 7 is the same thing as absolute value of positive 7. Both of those are just 7. So the absolute value of a negative x is equivalent to just take an absolute value of x, bring down the minus 4. Okay? Now, what we have right here is equivalent to what we have in the box above. So we're going to say, yes, this thing is symmetric about the y-axis. Okay? Next, let's test to see if this graph would be symmetric about the origin. No, let's not do that one next. Let's go in order. Let's see if this is going to be symmetric about the x-axis. That's the next one on tap. And when we test to see if something is symmetric about the x-axis, we replace y with a negative y. Okay? So that's going to look like negative y equals, and then don't change anything else. Okay? The right-hand side of that equation, and I'm looking right up here to replace my y with a negative y. Okay? But I'm going to write everything else down just as is. Now you need to ask yourself, is what we have here in purple equivalent to what we have in the box above? And that would be a no. And I can definitely see that if I would multiply both sides of this equation by a negative 1, okay? This purple equation is the same thing as positive y, right? Negative times a negative gives me the positive y equals, run the negative through the right-hand side as well, positive absolute value of x plus 4. So actually all these signs have changed here, and that's why we know that if we would go graph the absolute value, the y equals opposite of absolute value of x minus 4, we will not see symmetry about the x-axis. Okay? Now, for symmetry about the origin, recall from the purple box above that what we're going to do is replace both x with a negative x and y with a negative y. So that's going to look a little something like this. Negative y equals the opposite of the absolute value of a negative x, and then bring down the minus 4. Okay? So we'll have negative y equals the opposite of, recall from right up here, we discussed how the absolute value of negative x is equivalent to absolute value of x. Bring down the rest of it. Again, like we did right up here, if we want to run a negative through everything in that equation, either multiply by negative 1, divide by negative 1, this orange equation is equivalent to positive y equals positive absolute value of x plus 4, and that's not the same thing as what we have up here. Okay? So this thing is not going to be symmetric about the origin. Now, y'all, think about what we're doing with what we just learned. Okay? Back in section 2.6, and you don't ever graph anything just by drawing it like this, okay? This is like illegal, all right? But remember our shortcuts to graphing an equation, okay? We're going to graph y equals absolute value of x. Remember, that's the V-shaped. And then with the minus sign, That's a reflection about the x-axis. So what I am, okay, just quickly sketching here, is just the graph of y equals the opposite of the absolute value of x. And then what the minus 4 does, recall, is it moves everything down 4 units. So just really quickly sketching this. Look at this red graph right down here and think about what types of symmetry do you see? Well, I see symmetry about the y-axis. If you would fold our paper along that dashed yellow line, one part of our graph would lie on top of the other part of our graph, okay? And so then we would know that we have symmetry about the y-axis. That's what it means. Okay, if this thing was symmetric about the x-axis, then we'd have to have not only that going on down there, but that going on up there. And we don't have that. Okay, that's not what the graph of y equals negative absolute value of x minus 4 is. We also don't have the symmetry about the origin here. So that's a no as well. All right, so that's what we're really talking about, looking at it pictorially, okay? But here are your tests for symmetry. Let's practice that again, okay? I'm going to erase this so we'll have enough room to practice our tests for symmetry here. For number 10, I'm testing the equation x equals y squared plus 3. Okay, that's what my reference is. And I'm going to test to see if this thing is symmetric about the y-axis first. Okay, remember the test to see if something is symmetric about the y-axis, you replace x with a negative x. So now my equation looks like negative x equals y squared plus 3. Which, y'all, if you run that negative through, that's equivalent to x is equal to the opposite of y squared minus 3. And that is not the same thing as what is in the box. The signs are different. So this thing is not going to be symmetric about the y-axis. All right? Okay, next we're going to see if this graph of x equals y squared plus 3 is symmetric about the x-axis. This is where we replace y with a negative y right there. And so our equation is going to look like x is equal to negative y squared plus 3. So this is equivalent to x is equal to, hey, let me come up here, and what does negative y squared mean? It means to take negative y times negative y, and negative y times negative y is actually going to be a positive y squared. So negative y squared is the same thing as just y squared because of the exponent of 2. Bring down the plus 3. And you know what we got going on here? This thing is equivalent in signs and everything to what we have in the box above. So this thing is going to be symmetric about the x-axis. Okay? Next, we're going to see if this thing is symmetric about the origin. This is where we replace both. An x with a negative x and a y with a negative y. Okay? Ooh, that's an ugly 3. There we go. A little bit better. So this is a negative x equals, now remember, negative y squared is the same thing as just y squared. But when we take this negative and run everything through, we'll have positive x equals the opposite of y squared minus 3. So this, again, does not agree in sign with what we have above. So this thing's not symmetric about the origin. All right, we'll do another example coming up.